Hey everyone, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at Lesson 2 from Chapter 6, which is looking at dividing rational expressions. So when you're dividing rational expressions, we're going to follow similar rules, once again, that we would for a regular fraction. So, very shocking. So, say, for example, we were to look at 3 over 8 divided by 9 over 6. So what we would do is we would first flip our second fraction and change the operation to multiplication. So you'd have 3 over 8. So switch your operation to multiplication and then flip your second fraction. So it becomes 6 over 9. Then what we can do here then is we can start to simplify. So 3 and 9 have something in common. They can both be reduced by 3. So 3 becomes 1 and 9 becomes 3. And we can also reduce the 6 and 8. That can be reduced by a common factor of 2. So we're left with 3 here and 4 on the bottom. Once again, you guys can notice actually right here we have 3 and 3. So that means that these two numbers here can also be reduced by a common factor of 3, so that leaves with just 1. So we have 1 times 1 on the top is just 1. Then we have 4 times 1 is 4. So our fraction resulting from 3 over 8 divided by 9 over 6 is 1 over 4. So when we're dividing rational expressions, we're going to multiply by that reciprocal, or as I like to put it, it's called the switch and flip method, which we just did above here. So you first start by switching the operation to multiplication. So you switch the operation, flip the second rational expression. Then all we do is we just use multiplying to solve. So we're going to look at the first example in your notes, working with the non-permissible values and actually dividing fractions. So here we're going to simplify the following rational expression. Then we're going to state the non-permissible values. And I typically like to start with the non-permissible values first, just because it allows me to work with each of those denominators or each of those little areas separately. So I break it down to its factors. So that way when I get down to actually simplifying the rational expression, I don't have a bunch of work going on at the same time and it gets a little bit overwhelming. So one thing that's really important here is that when we're talking about the non-permissible values of when we're dividing rational expressions, you have to consider everything that could be a denominator at some point. So right now we have this denominator and this denominator. One thing we also have to consider as well is that when we flip this fraction, this numerator becomes the denominator. So we also have to consider the non-permissible values for this fraction. So there's 3 things we have to consider for those non-permissible values. So let's look at our first one here. So here we have x squared minus 4x. So what we do is we want to look at when those will be equal to 0, so we set that denominator equal to 0. Then when we have 2 terms, we could either look at your options would pretty much be pulling out a common factor or have to be difference of squares. And 4x is not a perfect square, so we wouldn't use the difference of squares method. So what you'd have to look for is pulling out a common factor. And really the only thing in common between these 2 terms is an x. So you have x, and what you're left with is x minus 4. Then what we do is then we're going to break these off into 2 little sections here. So we take our first factor, so that's just x. We'll set that one equal to 0. X is already by itself, so this one here tells us that x cannot equal 0. For our second factor, we set x minus 4 equal to 0 and solve. So we want to subtract 4 over, so we're going to add 4 to each side. And we get x is equal to 4. So x cannot equal to 4 and x cannot equal to 0 so far, just looking at that one denominator. Then we can move over to the second one. So if you want to label this one number 1, if you guys want to label this one up top number 2, then we'll do the bottom, we'll do that one last. So what we're going to do is we're going to look at x squared plus x minus 6. We'll set that equal to 0. So when we have 3 terms here, we really have to, some of our only options are factoring or using the quadratic formula. And in this case, it's always a little bit less work to use factoring. So let's try and do that first. So when we're doing factoring, you're looking at your product and sum method. So you want to look at the product of your first and last term. So be 1 times negative 6 is negative 6. And then your sum is this b value, which is positive 1. So you want to look for 2 numbers that multiply to negative 6 and have a sum of positive 1. So because we have a negative product, one has to be negative, one has to be positive. And because we have a positive sum, it means that our larger number is going to be positive. So think about 2 numbers that multiply to negative 6 and have a sum of positive 1. And that would be 3 and negative 2. So now we're going to move into just a little bit of a shortcut for factoring. So when we're factoring, these are essentially the numbers that are connected with x. So we have 2 brackets. We're going to put x on the left side, and then these values go in each of those brackets. So if this is a positive 3, we're going to write plus 3. Then if this is negative 2, we're going to write subtract 2. And those become each of our factors. And then don't forget to set this equal to 0. So now we have it broken down into those factors. Now what we can do is set each of them equal to 0 and solve. So our first one here is x plus 3 is equal to 0. So here we're going to subtract 3 to move it to the other side. And so here we have that x cannot equal negative 3. Now we're going to do the same for our second factor. So here we have x minus 2. We'll set that equal to 0. And we're going to add 2 because that's subtracting 2. So add 2 to each side. So you will find that x cannot equal positive 2. And to do the third one here, I'm just going to scroll down here. So here we'll be looking at x squared plus x minus 20. So once again, here we have 3 terms. So we're going to use that factoring method. So we're going to be looking at the product and sum. So here it's a product of your first and last term. So that's negative 20. And then the sum is just that b value, which is positive 1. So once again, think about 2 numbers that would multiply to negative 20 and have a sum of positive 1. So that there would be 5 and negative 4. Then using that shortcut, once again, we'll write 2 brackets. We're going to put x on the left side. And then these numbers go inside of each of those brackets. So we have a positive 5, so we'll write plus 5. Here we have negative 4, so we'll write subtract 4. Then we're going to set that equal to 0. Then what we're going to do is we're going to write each of those, or break them down into their factors and set those ones equal to 0. So we have x plus 5 is equal to 0. We're going to get rid of this add 5, so we're going to subtract 5. And here we have that x cannot equal negative 5. Then for our second factor, we have x minus 4 is equal to 0. So to get rid of minus 4, we want to add 4. So then we have x cannot equal positive 4. Now when you have a bunch of numbers like this, what we want to do is we just want to write a little overall summary of what we found. So overall we found that x cannot equal, so our first number there, a little bit hiding there from the screen, was 0. Then we had positive 4, negative 3, positive 2, negative 5, and we don't have to repeat this positive 4 because it's already in our list. So this here is a list of all of our non-permissible values. So now that we have our non-permissible values, now we can actually look at solving this equation, or sorry, solving this expression. So this will be step number 2 here, is to actually simplify. So I'm going to start by rewriting our expression here. So we have x squared minus 4 over x squared minus 4x divided by x squared plus x minus 6 over x squared plus x minus 20. So my first step here is I want to apply that switch and flip method. So I'm going to rewrite my first fraction exactly as I see it. Then I'm going to switch the operation to multiplication and flip my second fraction. So it becomes x squared plus x minus 20 on the top, and then x squared plus x minus 6 on the bottom. So then this just goes back to 6.2, that first video of the lesson that we did, where we're just going to be breaking them down to the factors and then canceling out any common factors. So let's first start with this numerator in our first fraction. So here we have x squared minus 4. So to break that down to the factors, remember when there's only 2 terms, you either A, look for pulling out a common factor, or B, using a difference of squares. So here we don't have any common factors, and x squared and 4 are both perfect squares, and they're being subtracted. So this means that we're dealing with a difference of squares. So using that shortcut I showed you guys in chapter 5, you're going to take the square root of your first term, which is x, and that goes on the left side. Then you take the square root of the second term, which is 2, and you put that on the right side. Then one gets a plus sign, one gets a minus sign, and then you're done. Then we can look at breaking apart the factors for each of our other terms, which we've already done when we did our non-permissible values. So when we were looking at x squared minus 4x, we had x times x minus 4. And then in our second fraction, this x squared plus x minus 20 was x plus 5 and x minus 4. Then for x squared plus x minus 6, we had x plus 3 and x minus 2. So remember, these are at the beginning of the video if you're just trying to think back to how we did that work. So from there, now that we have everything broken into their factors, now we just have to cancel out any things that are in common. So I always start off with my first term here. So here we have x plus 2, and then just see if it's anywhere in the bottom. So we have x, x minus 4, x plus 3, and x minus 2. So that actually doesn't exist there, so we have to leave it. Moving on to x minus 2, we have x, x minus 4, x plus 3, and here we have an x minus 2, so cancel those both out. We can move over to x plus 5. So we have x, x minus 4, x plus 3, so that one there has nothing in common. Then moving over to x minus 4, we have x, and then x minus 4 right here, so let's cancel that out. So we've gone through everything, checked for anything that's in common, so now all we do is rewrite this, whatever's left over. So we have x plus 2 times x plus 5 all over x times x plus 3. So then just always, what you should always do is just make sure, go back and double check to make sure that there's nothing in common with those terms, and if not, then we are actually all done this question. We've stated those non-permissible values, and we've divided the two rational expressions. So that's everything here for this video. So if you guys have any questions, make sure to come see me in class or text me on Remind 101.